Our project team set out examining information behaviors of engineers by reading the case textbook, Chapter 11, Research by Occupation. The section on engineers gave us some quick insight into their information behaviors, and we were presented with additional research to follow. We selected relevant research mentioned in the chapter and then chained through citations to reveal more research related to our query. In the end, we uncovered a significant amount of research about information behaviors of engineers and several other interesting facts. This trail of literature we followed provided a solid theoretical framework for helping us understand the infamous engineer. Of particular note were articles by Pinelli, Kwasitsu, Leckie, Ellis, Hertzum, Anderson, and Mueller. As called for in Assignment 3, our group got excited in particular with Dupree's 2007 article, Information Needs and Information Seeking Behavior of Engineers, a Systemic Review. And we posted it to the Module 6 GoPost forum for class review and discussion. As one might guess, this article delivers a comprehensive perspective of engineers' information behavior, and you are encouraged to read it if you'd like a good sense of how engineers behave when they seek, gather, and use information. Engineers have actually been studied quite extensively for their information behaviors. One could probably argue that in their professional roles, they as a group have consistent patterns in seeking information. Engineers have been shown to be different or distinct from scientists, for example, and you might think that they were quite similar. So forget any stereotypes you may have about engineers. For their information behaviors, they turn out to be a rich, fruitful group to observe. To facilitate your understanding of our engineer's IB, or information behavior model, it helps to know that our model for this project is a process-oriented model, developed to describe an engineer's information-seeking behavior. It describes an information-seeking process as a situation emerges for your typical engineer, and eventually how the process is resolved. Elements in the model are supported by relevant theoretical constructs and explanations. For this project, we also wanted to tie our query into some relevant, meaningful general theory that would help explain the information-seeking behaviors of engineers. We found that Leckie's information-seeking for professionals model described an information-seeking process that engineers would likely fit into. We also chose Wilson's information behavior model as a foundation for understanding engineers' information behavior. This model seemed appropriate so we could examine intervening variables more closely, and thus give us a better sense of why engineers do what they do and how they go about it when seeking information. So what I'm going to do is present and describe both Leckie's and Wilson's models and talk about how we use them to ground our fieldwork. Then, after analyzing the data collected from our fieldwork, we mapped our observations to these models. This really helped establish where variables fit and when they occurred. I will describe this in each model. By mapping our fieldwork to these models and to related theoretical constructs, we developed a process-oriented IB model for engineers. I will describe this in the final part of this segment on group-specific IB models. Leckie, Pettigrew, and Sylvain's information seeking for professionals model serves partly as a foundation for our study into the information seeking behaviors of engineers. The model emphasizes the roles and associated tasks undertaken by professionals in the workplace. The model also seeks to identify information seeking characteristics that might influence how a professional will seek information. Awareness of information sources and the availability or accessibility of an information source are significant intervening variables. Finally, outcomes are the results of an information-seeking process, and of which can be fed back into the process until an information need is resolved. And so, since engineers are certainly thought of as professionals, the Leckie model enabled us to analyze our engineers more fully, and to begin to understand them in context, and then design our fieldwork, at least partly within its framework. Wilson's information behavior model was also useful and relevant to our exploration into the information-seeking behaviors of engineers. Since information seeking is a process and is particularly problem-based or task-oriented for engineers, our group was intrigued by Wilson's identification of a context of information need, activating mechanisms, and intervening variables leading to various expressions of information-seeking behavior. Engineers are task-oriented problem solvers. For our fieldwork, Wilson helped us explore the impact or influence of intervening variables in a given context, and the things that activate or motivate an engineer to seek information in particular ways. Finally, Wilson's model helped to identify variables and characterize our field subjects for their information-seeking behaviors. Again, this helped to formulate our own Engineer IB model for this project. So our team needed to find out how engineers seek and use information. We wanted to find out what makes engineers distinctive for their information-seeking behaviors, what makes them a knowledge community, or what factors might influence them as they go about their business. In research literature on engineers, we found many factors can influence their information-seeking behavior, though the constructs generally emphasize various dimensions in the physical, social, cognitive, and contextual domains. With this in mind, our team felt we had a supporting theoretical framework with which to build a descriptive, process-oriented model for engineer information behavior. As was described in Part 3 of this project presentation, our fieldwork was conducted at EDT, or Engineering Design Team, in Beaverton, Oregon, which fortunately and generously provided a suitable environment to conduct our fieldwork. This is a private firm, and in our case, it provided a small team of engineers who worked together. So now let's take a look at the Information Seeking for Professionals model and try to map out our field data to the components of that model. For work roles, we were able to identify a number of positions within the firm, and they are listed here. Various tasks associated with work roles were identified. Characteristics of information needs in this environment were revealed in the data. EDT sources of information are generally easy to access. To the extent engineers were aware of information sources seemed to accentuate the principle of least effort. An element of feedback was identified in the information seeking process, and outcomes were shown to complete tasks, achieve goals, or to develop products. Now let's move on to Wilson's information behavior model and see if we can draw a connection to our fieldwork. Under the context of information needs, we found several factors that could influence information-seeking behavior. Initial activating mechanisms are related to project specifications and research and development. Potential intervening variables are identified. These variables were interesting because they seem to match those which are prevalent in the research. Once passing through the intervening variable stage, the process enters into a new activating mechanism. EDT engineers are self-sufficient, though they operate in a social network by how they gather and share information. Finally, the basic information-seeking behavior identified according to Wilson's model is that our EDT engineers are active searchers who satisfy both immediate and long-term project information needs. Basically, we start out with a client's specifications, or needs for a particular product. These needs are influential but are outside of the specific problem or task-oriented information-seeking patterns of engineers. That's why we see it separated in a dashed box. Just as in the Information Seeking for Professionals model, we recognized and sought to address how work roles influence an engineer's information-seeking process. We found that engineers are characterized as technologists who take on a variety of roles in their work. An engineer's work is fundamentally technical and typically geared towards creating products, processes, or services. Engineers are goal-oriented. They seek to fulfill specific objectives in a task completion process. Engineers are expected to make informed decisions in the context of a given design problem. There are varying factors or characteristics affecting information needs at this point. Though perhaps not exhaustive, these variables include demographics, such as age, profession, discipline or expertise, career stage, geographic location, context, which are situation-specific needs and are prompted internally or externally, and also have to do with the organizational structure. Frequency, which has to do with recurring needs or new needs. Predictability are those anticipated needs or unexpected needs. They can have to do with the project scope or the project cycle. Importance. This is the degree of urgency based on time or budget, perhaps. And task complexity. Basically getting at how easily resolved or difficult an information need is according to the complexity of a task. We now come to the design problem stage, where many tasks are realized and set in motion. It is at this stage that client needs, various work roles, and information need characteristics come together and are defined in such a way as to enable a transition into the information seeking process. A design problem can be affected by task uncertainty and complexity, and this may impact how an engineer seeks an information source. The information seeking process is now more directly underway, and in this model is considered to be problem-based, task-oriented, and iterative. Accessibility refers to the ease with which individuals approach information sources in order to use them, and is shown to be a significant factor affecting information seeking in engineers. Many physical or psychological variables might influence how an engineer will proceed. Physical variables might be location, availability, proximity, ease of access, collaboration, and environment. Psychological variables might include ease of use, relevance, familiarity, importance, and quality, among others. With the effect that accessibility might have on this information-seeking process, now an engineer begins to identify potential sources. He or she starts to distinguish between and chain through various sources as they are relevant and appropriate for the task. For engineers, multiple carriers of information may be present, meaning an engineer might have multiple sources of information and might use them in a relative way to solve a problem or complete a task. Sources then might turn out to be documentary or interpersonal, either of which possesses certain characteristics. For documentary sources, available resources can be affected by several variables, such as format, location, and collections. Interpersonal factors usually involve communications and can occur with colleagues, clients, vendors, and even librarians. If all the model components line up so far, we should be at the retrieval stage. This is the point at which an engineer has extracted information from a source and feels reasonably confident that it will fulfill the information need. Next, an engineer will use the selected information in some way, thus ending the information-seeking process, and then he or she can consider the task complete. Feedback is shown to occur at the source stage and at the task completion stage, and at these stages the process is an iterative one, directing an information-seeking process back to a stage that accommodates an information need. Finally, a product, service, or process is developed, and the information-seeking and retrieval process concludes. It is assumed an engineer or a team of engineers has satisfied a client's specifications. Next, we move on to Part 5, covering the practical implications of engineer information behaviors. Please click to proceed to the next section.